Okay, in this video we're talking about functions, and there's quite a bit to go over here. A function is pretty similar to like a graph with y equals or something. It just has f of x equals instead. So where we might see the graph be y equals 2x plus 1, which is a straight line, the function would be f of x equals 2x plus 1. It's just different notation which lets us sub in x values a bit easier. So let's see an example. We've got this function here, f of x equals x squared plus 1. And what that actually represents is this graph. Anyway, let's plug in some values. So f of 3 is going to be 3 squared plus 1. You just put in the x values, so that's 10. F of 5 is 5 squared plus 1, which is 26. F of 0 is 0 squared plus 1, which is 1. F of 1 is 1 squared plus 1, which is 2. So that's how functions work. When you have the number in the brackets there, that means you're subbing that number in place of x. And for example, f of 5 being 26, graphically would represent, well, when I'm at 5 on the x, I'm going to be at 26 on the y, just like that. So that's function notation, but there's still a bit more that we do with functions. So next thing we do is we check whether things are functions. And we do that using something called the vertical line test. So here, this first one is a function, because if I draw vertical lines through the entire thing, they'll only ever hit the graph once. Same thing here, only ever hit it once. But this last one is not, because the line hits the graph twice. So let's do a couple of examples. Vertical line test here. Draw your vertical lines down. Yes, it is a function. Because it passes the vertical line test. This one, uh-oh, so that hits the graph twice. No, it's not a function. Because it fails the vertical line test. All right, next we need to talk about domain and range. So domain and range are basically the x values and the y values that your graph can take. Domain's the x and range is the y. And we tend to use greater than or less than signs to represent this. So just for revision, greater than or equal to looks like that, which means you would include 3. This one, x is less than 2, means you don't include 2. And you draw that with a little open circle if you don't include it, or a closed circle if you do. If you want to say x is in between two values, you basically put it in between two values with the less than signs either way. Okay, so let's do a couple of examples. We got this graph, x squared plus 1. We're going to find the domain and range of that. Here it is. So the domain is going to be any x value we want, because I can keep going left and right forever, and I'll always find this red line, no matter how far left or right I go. I just have to go really far up. So the domain will be any x value. And we have a really nice way of writing that. We write x, and then this symbol that looks kind of like an E, and then R, with like a double line on the R. So what that means is in, and then this bit here is the set of real numbers. X is in the set of real numbers. Okay, range. So this gets a bit trickier, but you can see it never goes any lower than y equals 1. So the range is going to be y has to be greater than or equal to 1. You have y being equal to 1 when it hits that point, but it has to be greater than or equal to 1. Now, next one we got 5 over x take 2. Let's have a look. So we have a hyperbolic function here. And it looks like we've got an asymptoted x equals 2. So the domain, basically what you can write is, you can write, well, x is in R, just like that, like what we've written above, but x does not equal 2, just like that. For the range, you can do a similar thing. So y is in R, but y does not equal 2. Y does not equal 0, sorry. So y is in R, y does not equal 0. And that happens just because, well, you've got this line at 0 and the graph never touches it. It asymptotes there. This is just a hyperbolic function like we've seen before. Okay, so that's good. The other way you could write this domain is you could write x is greater than 2 or x is smaller than 2. If that makes sense. So it could be bigger than 2 or smaller than 2. It just can't be 2. Same here. You could write y is greater than 0 or y is less than 0. All right, sine of x. Let's have a look. So it seems to go on forever in both directions. So the domain is going to be x is in R, just like that. The range, now, it goes down to -1. It goes up to 1. So y is always trapped between those two values. In fact, I can show you. Y equals 1 is that blue line, and y equals -1 is that green line, and the graph is always trapped between the blue line and the green line. That's our domain. That's our range. So -1 is less than or equal to y, which is less than or equal to 1, just like that. 3x plus 2 is our next graph. Seems to go left and right forever, and it seems to go up and down forever. So our domain will be x is in R, and our range will be y is in R, just like that. Next graph, root 1 take x squared. Just like that. It looks like the top half of a circle. So you can see x goes from -1 up to 1, and y goes from 0 up to 1. So -1 is less than x is less than 1, and the range will be 0 is less than y is less than 1, just like that. Now, I'd encourage you, if you're feeling confident, to graph on your calculator when you try these questions. I've done it on Desmos here just so that it's a bit quicker, but you want to get used to using your calculator for a test or something like that. But if you can't do that quite yet, Desmos is fine for now.